Welcome. Again, we are going to cover questions 21 through 25 in this video. Okay, so now we're moving into one-to-one functions and inverses. If you remember, when you have an inverse, how the domain and range are related. So the domain of a one-to-one function is the same as the range of its inverse. And the range of a one-to-one function is the same as the domain of its inverse. So if you remember, if you have x comma y, the inverse is y comma x, and so it makes sense that the domain and range would just trade places. All right, so let's move into question 22. It says, complete the table to determine the effect of the number of compounding periods when computing interest. Suppose that $17,000 is invested at 3.8% for 10 years. Under the following compounding options, round answers in the second column to the nearest whole number, round answers in the last column to the nearest cent. All right, so first let's talk about our two formulas that you're going to see in this section that you're going to definitely want to be on your reference sheet. Here are the two different formulas that you'll use. Now, I'm going to start actually talking about PERT. The compounded continuous is the only time you use PERT. We're only going to be using it on that last question, all right? That's why it says it's not applicable for the end value, okay? So we're going to use PERT on the last one. And then for the other problems, we're going to be using the compounded interest formula. Just a reminder that P stands for the initial value or the principal. R is the interest rate, but you have to get rid of the percent. And then N, they always have to give you a word, and that's how many times it's been compounded per year. And then T, of course, is just the time in years. All right, so let's start with the N values for our table. If something is compounded annually, that means it's compounded one time per year. If something is compounded quarterly, that means it's compounded 4 times per year, like there are 4 quarters in a dollar. If something is compounded monthly, N would equal 12 because that means 12 times per year. And then for daily, N would equal 365. Now, we're going to go ahead and label the other variables in our formulas. So P will always be 17,000. R will be 0.038. So notice that I get rid of the percent. I can either divide by 100 or simply move the decimal 2 to the left. And then T is equal to 10. All right, so what I'm going to do is I'm going to write the formula out on the side for you of the table, and that might help you. And then I will show you the results. Everybody has a different type of calculator, so I'm not sure what type of calculator that you have, but you should be able to raise things to the power. All right. All right, you can see that I've written out everything for you. Notice that I'm just plugging the different values into my formula. However, the n is changing based on the table. So for when n equals 1, this would be the formula that I use. When n equals 4, you can see how my formula changes only in the n position, right? And on your final exam, you'll just be answering one question about this and one question about compounded continuously. You won't have to do a whole table. But it's good to practice with all the different ones. So you should be able to type this whole thing into your calculator. Remember that this part here that I'm highlighting now in blue is exponent. You're going to be raising it to a power, and the operation is multiplication. So this is 1 times 10, 4 times 10, 12 times 10, 365 times 10. You can type the whole thing in at once if you're very careful. All right, so now I'm going to also show you the compounded continuously, which is 17,000 e raised to the 0.038 times 10. So this blue part as well is exponential, of course. Now I'm going to now write in the answers for you. All right, there you go. That is the completed table. Okay, let's move on now to logarithmic properties. So on number 23, we're going to write the log as a sum or difference of logarithms. We're going to simplify if possible, and we're just rewriting the logs. Okay, so I have several pieces here. Remember that if it's raised to a power, you can actually put that in front of the log. So I'm going to have the log of x base 12. So the 5 is going to go to the front. And then remember, division is subtraction, so minus, And then I'm going to have the log of y base 12 minus the log of z base 12. And anything on the denominator we have to show by having a minus in front of that log itself. So remember, if it's multiplication, we would use addition. If it's division, we're going to use subtraction. All right, so that would actually, I can't simplify this, so this would be my answer here. All right, let's try 24. Very similar problem. I'm going to have 7 in the front of the log. So 7 log of m base 3 minus, because of this division here, 5 log of n base 3. So once again, the 5 is going to the front. And then minus the log of p base 3. And I cannot simplify that, I'm finished. All right. Now we're going to solve this exponential equation. We're going to simplify as much as possible. These have similar bases, so I can actually convert 64 to base 4. So I have already 4 raised to the negative 3w plus 15. And then 64 I can rewrite as 4 to the third power. Because 4 to the third power is 4 times 4 times 4, which is 16 times 4, which is 64. All right. And once I am able to convert it, I can now set those equal to each other. So I'm going to have negative 3w plus 15 is equal to 3. And then from here, I can just solve. So I'm going to subtract 15, which gives me negative 12. And then I'm going to divide both sides by negative 3, which gives me positive 4. And so my solution set is positive 4. All right, I hope this video helps you. There are more to come.